Welcome to the debate. If you work in, modern industry, agriculture, or really any sector that's trying to digitize its operations, you are intimately familiar with a specific kind of pain. It's what I call the integration tax. You buy a state-of-the-art ERP system, you install expensive IoT sensors on your machinery, and you subscribe to a sophisticated SaaS analytics platform. Individually, these tools are brilliant, but together, they're silent. They exist in silos, and they just don't talk to each other. Unless you spend, 6 months and a small fortune on custom integration projects?
It's the Tower of Babel problem of the digital age. I mean, everyone is speaking, but no one is understanding anyone else without a very, very expensive translator sitting in the middle, charging by the hour.
Precisely. And that is exactly where we're focusing today. We are dissecting Tritom, a Finnish data intermediation service that was recognized by Traficom in early 2024. Now, this isn't just another integration bus or, a slightly better API manager. It claims to be a fundamental rethinking of how data moves, specifically designed to align with the EU Data Act. They call it a loose coupling model that radically separates the business, legal, and technical layers of data exchange.
Loose coupling is a fantastic engineering principle, but it is often a nightmare in operational reality. So the core question we're debating today is pretty simple. Does Tritom's model actually liberate organizations from vendor lock-in and that dreaded integration bottleneck? Or does it just take the technical burden off the service provider and, dump it right onto the client's IT department?
I'll be arguing that Tritom represents the upper control level for the data economy, a neutral, scalable infrastructure that functions like a utility. It creates true independence by making the provider invisible and, crucially, removing them from the critical path of innovation.
And I'll be taking the position that while that utility analogy is seductive, the reality requires a level of technical maturity that most companies simply lack. And I'm also highly skeptical about relying on a legal layer to secure data once it technically leaves the pipe. It sounds great in a slide deck, but the real world is messy.
A fair skepticism. Let's start by establishing the positions clearly. My stance is grounded in the architectural philosophy of the Data Act. The current model of data exchange is what we call N times N. If I have 10 partners, I need 10 different API integrations, 10 different security reviews, and 10 different maintenance cycles. Tritom changes the physics of this to N times 1.
That is the standard pitch for every enterprise service bus since the late 90s. Though, everyone promises write once, run everywhere.
But the execution here is radically different because of who controls the connection. And this is the crucial point found in the Tritom in a nutshell documentation. In a traditional centralized platform, think of a major cloud provider or massive industry platform. The platform operator is the bottleneck. If I want to launch a new data product, I have to ask them to open a port. I have to ask them to map a schema. I have to wait for them to approve a partner.
And usually pay them a hefty consulting fee to do it.
Exactly. With Tritom, the dynamic is flipped. The enterprise client defines their own data products. They generate their own connectors using the Tritom interface. They do not need to ask Dataspace Europe Ltd, the operator, for permission. They don't need to pay them for technical labor to launch a new product. The bottleneck is removed because the operator is passive regarding the content. The client is sovereign.
Passive or absent. See, I look at the same facts and I see a complexity shift. You say the client is sovereign, which sounds noble. I say the client is abandoned. In the traditional model you critique, yes, I have to wait for the platform provider to build the API. But they build it, they maintain the security patches, they ensure the uptime. In the Triton model, the source material explicitly states the client generates the connector. That means I am now responsible for the endpoint. I am responsible for ensuring my data semantics match the output. If I'm a mid-sized logistics company, do I really want to be in the business of maintaining telecommunications infrastructure? I suspect for many, the bottleneck of a provider is actually a safety net they're happy to pay for.
I think you're underestimating the agility cost of that safety net. Let's move into our first core area of debate, the bottleneck argument and technical independence. The source material highlights a specific metric that really caught my eye. Organizations were able to send data within 3 to 4 hours of starting work. I mean, in the world of enterprise integration, where projects are measured in quarters, hours is a revolutionary timescale. This is possible purely because of that loose coupling architecture.
Okay, let's unpack loose coupling for the listeners, because it is more than just a buzzword here. It dictates the entire workflow.
Right. In a tightly coupled system, the sender and receiver need to know everything about each other: formats, timing, error handling. If one changes, the other breaks. Tritom uses a containerized connector. You spin up this container in your environment, whether that's on-premise, in your factory, or in a private cloud. This connector acts as a standardized postbox. You don't program the route to the recipient. You just drop the data in the box. The Tritom network handles the routing based on the business layer configuration.
I will grant you that 3 to 4 hours to get the plumbing working, the actual TCP connection and encryption, is impressive. But I have to challenge the utility of that speed. A pipe is useless if you don't understand what's flowing through it. The material claims that there are no API meetings, but that assumes data is self-explanatory. If I send you a stream of integers from my factory floor and you don't know if that is temperature, pressure, or vibration, the connection is worthless. You still need a meeting to agree on the semantics. So have we really removed the bottleneck, or just moved it from the network engineer to the data scientist?
That is a valid challenge, but Tritom anticipates this. This is where the separation of the business layer comes in. The system requires the publisher to publish metadata descriptions alongside the technical connector. Think of it like the label on a can of soup. You don't need to call the soup factory to ask if it contains tomatoes. You read the label. In Tritom, before a recipient subscribes to a data stream, they review the metadata description in the catalog. It defines the semantics, units, frequency, data structure. The meeting is replaced with documentation.
Documentation that relies on the publisher being diligent. We all know how much developers love writing documentation. But let's look at the scalability argument found in the text. They compare Tritom to an automatic telephone exchange.
It is the perfect analogy for this operational philosophy. When you call your mother, the phone company connects the circuit. They don't care if you speak English, Finnish, or if you're sending a fax tone. They don't record the conversation to train an AI model. They just charge for the connection. Tritom is trying to be that for data, the invisible carrier. And this is vital for the independence of the client. That is Space Europe, Ltd., as the operator, is like the phone company. They enable the call, but they don't sit in the room with you.
And that brings us to the pricing model, which I admit is fascinatingly counterintuitive for the current tech climate. Most cloud hyperscalers, AWS, Azure, Google, operate on a consumption model. You pay for storage and, crucially, you pay for egress. Every time you move data out of their cloud, the meter spins.
Exactly. The egress tax is the biggest inhibitor to the data economy. Tritom flips this. You pay a license fee based on the number of data products you have active. You do not pay based on the volume of data or the number of transactions. If I have a machine health stream product, I pay a flat fee for that license. I can send 1 kilobyte or 1 terabyte. I can send it to 1 partner or 100 partners. The cost is the same. This incentivizes usage. It incentivizes high-volume, real-time data sharing, which is exactly what industrial automation needs.
It is a buffet model versus a la carte. I see the economic appeal, but I want to circle back to the complexity. In a phone call, 2 human brains do the decoding. If the connection is fuzzy, we say, "Can you repeat that?" In data streams, if a packet is malformed, the receiving process crashes. The material mentions that because of this loose coupling, there is no integration hook. Other platforms try to embed agents deep in your stack. Tritom stays at the edge. But doesn't this edge-only approach limit what the system can do? I mean, it can't optimize the data, it can't compress it intelligently because it treats it as a black box.
But that is a feature, not a bug. By treating the data as a black box, Tritom guarantees neutrality. It prevents the platform from becoming a competitor. This leads us perfectly into the second major topic, the 3 layers: business, legal, and technical. The brilliance of this architecture is that these layers move at different speeds. The technical layer, the Kafka streams, the encryption, needs to be fast, milliseconds. The business layer, the marketplace deals, moves at the speed of commerce, But the legal layer is where the real governance happens.
And the legal layer is where I have the most significant concerns regarding security and fraud. The source material is startlingly honest here. It explicitly states, Tritom cannot prevent fraud that happens outside the system.
No system can.
But let's play out the scenario. I'm a valid recipient. I pay for your crop yield data via the Tritom marketplace. I sign the digital contract. The connector delivers the data to my server. At that moment, the data is just a file on my hard drive. If I then decide to copy that file and email it to your competitor or pipe it via a side API to a forbidden third party, Tritom has zero technical ability to stop me. The pipe has done its job. The data has left the building.
That is correct. Just as a phone company cannot stop you from repeating a secret you heard on a call, if they could stop you, it would require invasive surveillance DRM, digital rights management, installed on your device, monitoring your keystrokes. That destroys trust and interoperability. Tritom's answer is the rulebook. The legal layer isn't just a click-through terms of service. It's a binding governance framework under the EU Data Act. If you violate the data usage terms, if you resell data you are only licensed to view, you aren't just blocked. You face expulsion from the ecosystem and legal liability under Finnish law.
So the security mechanism is the threat of a lawsuit?
It's trust through governance. In the B2B world, contracts matter. Companies don't casually break contracts because the liability risks are massive. Dataspace Europe Ltd acts as the referee. They don't watch the game, the data, but if someone commits a foul, they blow the whistle and eject the player. This is what allows the loose coupling to work. If you tried to enforce every rule with code, you would create a rigid, brittle system. By enforcing it with law, you keep the system flexible.
It's a reactive security model versus a proactive one. In a high-stakes industrial environment, say, nuclear plant data or proprietary pharmaceutical formulas, reliance on reactive legal enforcement feels risky. We can sue them after they steal our trade secrets is not a comforting sentence for a CISO.
But the alternative is total vendor lock-in, where the platform owns your data to protect it. Tritom chooses risk management over control. It enables the data holder to make that choice. And speaking of users making choices, we need to talk about the different types of users. This isn't just for massive corporations. This brings us to essential versus enterprise users and the fascinating example of the farmer.
This section of the material worried me about potential hierarchy. We have enterprise users, big agri-tech firms, food processors who have full IT teams. They create the data products. Then we have essential users, farmers, small entrepreneurs who mostly consume them. The material describes the essential interface as a wizard. It simplifies things, sure, but are we creating a digital class system where the big players define the rules and the small players just click accept?
I completely disagree with that framing. The essential license is about empowerment through abstraction. Let's look at the virtual ERP concept. A modern farmer is drowning in disconnected data. The tractor sends telematics to John Deere's cloud. The weather station sends data to a meteorological app. The green elevator puts quality data in a PDF. Before Tritom, the farmer had to look at 3 different screens. With the essential interface, a partner can offer a service product or palvelutote.
A service product. This is the bundle, right?
Yes, imagine a crop optimization service. The farmer logs in. They see the service offer. They click Enable. In the background, Tritom, acting as the upper control level, authenticates the tractor data, the weather data, and the grain data, and routes them all to the analytics provider. The farmer didn't have to build an API. They didn't have to hire a consultant. They just authorized the flow. It creates a virtual ERP where these disparate systems act as one.
The upper control level term is borrowed from factory automation, the layer that orchestrates the machines. I get the analogy, but here is my concern. The farmer is authorizing the flow, but do they understand the value? If I'm sending my soil data to a giant chemical company, am I getting paid for it? Or am I just feeding their AI model for free in exchange for a slightly better weather report? The interface makes the connection easy, but it doesn't necessarily balance the negotiating power.
And is a market problem, not a protocol problem. Tritom provides the mechanism for the farmer to say no, or to say, I will only share this if I get X in return. Under the Data Act, the farmer is the data holder. They have the legal right to control that data. Tritom gives them the technical button to exercise that legal right. Without such a tool, the data is locked in the tractor company's cloud, and the farmer has no leverage at all.
That is a fair point. A yes-no button is better than no button at all. But let's shift gears to the physical reality of this system. We talk about the cloud like it's magic, but it lives in servers. Tritom makes a very specific and I'd say somewhat controversial choice about where it lives.
It's a choice that defines its value proposition. Tritom runs Insignia Ltd's security classified server room.
For our international listeners, Insignia is the Finnish state-owned company that builds fiber optic sea cables. They're the backbone of Nordic connectivity. So Tritom is running on bare metal in a government-adjacent facility. It is not built on AWS. It is not built on Microsoft Azure or Google Cloud. In 2024, building a platform without the elastic scalability of the public cloud is a bold, almost retrograde move.
It is a strategic masterstroke for digital sovereignty. We discussed the pricing model earlier, avoiding the egress fees of the hyperscalers. But the bigger issue is geopolitical risk. The U.S. Cloud Act allows American intelligence agencies to subpoena data from U.S. cloud providers, even if that data is stored in Europe. By running on Cinia infrastructure entirely under Finnish and EU jurisdiction, Triton is insulated. If there's a trade war, if there's a change in U.S. privacy laws, or if a transatlantic cable is cut, Triton keeps running. It offers independence from international politics risks, as the source material puts it.
Critical infrastructure provider, Finnish soil, Finnish laws is a massive selling point. But we have to look at the trade-off. AWS and Azure aren't just hard drives anymore. They are ecosystems. They have massive AI engines, machine learning pipelines, serverless compute functions. By isolating themselves in the Cinia server room, is Tritom cutting its clients off from the most advanced tools in the world?
Not at all. And this is the critical distinction. Tritom is the connector, not the processor. If a client wants to pull data out of Tritom and feed it into an Azure OpenAI model, they can. Tritom is the transport layer. It moves the data from the source to the destination. If the destination is AWS, so be it. In fact, being platform agnostic is a strength. If you build your data exchange on AWS, you're locked into AWS. If you build it on Tritom, you can route data to AWS today and switch to a private local AI cluster tomorrow without rebuilding the network.
So Tritom is the road, not the factory.
Precisely. And the road needs to be neutral. It shouldn't charge tolls based on what car you drive, and it shouldn't look in your trunk. It shouldn't steer you toward a specific gas station. That is what Tritom offers. A boring, reliable, sovereign road, and returning to the concept of independence. Because the road is neutral, the client remains the master of their journey. Dataspace Europe Ltd is just maintaining the pavement.
Boring is an underrated quality in infrastructure. I'll give you that. However, my conclusion remains cautious. We've discussed the N×1 efficiency and the essential user wizard. But the success of this entire model depends on adoption. The network effect is brutal. A telephone network with 2 people is useless. A telephone network with 1 billion people is indispensable. Tritom is trying to bootstrap a network from scratch. They are betting that the pain of the integration tax is high enough that companies will take the leap and install these containers. But companies are lazy. The path of least resistance is often just staying in the Microsoft or Amazon ecosystem and paying the extra fees.
That has been the historic trend, yes. But the regulatory landscape has shifted. The EU Data Act is forcing companies to open up their silos. They have to share data now. Doing that via custom APIs for every request is financially unsustainable. Tritom isn't just betting on frustration, it's betting on the law. It provides the easy button for compliance. By decoupling the service provider from the daily transactions, it scales infinitely. It turns integration from a consulting project into a configuration task.
It's a rigorous governance machine, I will admit. The separation of the legal contract from the technical pipe is academically beautiful, but I suspect the friction will be higher than they claim. Generating a connector sounds easy until you hit a firewall issue. Metadata descriptions sound great until you realize your supplier didn't update them. The human layer is always the point of failure.
The human layer is always the challenge. But Tritom gives humans a framework where they can collaborate without needing to trust each other blindly. They trust the governance, not the person. It's an industrial automation system for the business world. It connects the isolated processes to create a holistic view.
Well, we will see if the market agrees that loose coupling is worth the tightening of the rules. For now, check your connectors and definitely read the rulebook.
Indeed. We hope this deep dive into Tritom's architecture has illuminated the difference between just moving data and building a sovereign data economy.
See you next time on The Debate.